This is January 05 question 3. An object initially at rest can move along a straight line. From time t equals 0, it accelerates uniformly until t is equal to t1, when its acceleration suddenly decreases to 0. It continues until t equals t2 with 0 acceleration. The top graph shows how the acceleration of A depends on time. So there's the top graph. Then the next graph then shows a velocity time axis, which you have to fill in, and the third graph shows a displacement time axis. So the first part of the question in part 1, sketch graphs to show the variation of time t with the velocity v of the object, and then the displacement s. So first of all, the velocity v, you can see here that the acceleration has got a constant value, and that means that the velocity is constantly increasing. So therefore it's got a positive gradient, but it's constant because acceleration is constant. You can see then from time t equals 1 to t equals 2, its acceleration is 0. That means it's travelling at a constant velocity. And that's the first part of the graph. The second one then, we're going to refer to the velocity time graph above it. So we need to show displacement time this time. So we can tell that it is constantly accelerating here. And that means that the first part of the displacement graph is going to be a curve. If it was decelerating, it would curve the other way. Then it continues to move, but it has a constant velocity. And a graph with a constant velocity then is going to have a straight line. And that's hard to put in there, but something like that. And that's the shape of your two graphs. There was 2 marks for each of them, for each part, 1 part for each part of the graph. Part 2, and this question again has come up for the last couple of years. State how the magnitude of the displacement at time t equals t2, which is this one here, may be obtained from the velocity against time graph. And that is, of course, the area underneath the graph. So you either shade it in and explain it's the area of the shaded part, or you just write down that it's the area between the line and x-axis or time axis. You could go a wee step further and explain how to get it. You could say area is equal to the half the base, which is not t1. Okay, so it's half t1 times the height, which is v, and then it's plus this bit here, which is a rectangle, so that the base is t2 minus t1 times v. And that's another way that you could write that area there. Next part of the question. A vehicle is travelling at a speed of 120 kilometres per hour along a straight road. The driver brakes, causing a uniform retardation or deceleration of 8.7 metres per second squared. Show that a speed of 120 kilometres per hour corresponds to a speed of 33 metres per second. So 120, now when I do this I always write kilometres over hours because it helps me to see the conversions. So to convert kilometres into metres, you have to multiply by 1,000. To convert hours into seconds, you have to multiply by 3,600. And therefore there's your sum. 120 times 1,000, and then it's divided by 60 by 60, which is the number of seconds in an hour. And that will give you an answer then of, see what it is, 33.3 repeated ms to the minus 1. Calculate the distance travelled from the moment of applying the brakes until the vehicle comes to rest. So we know from above the initial velocity is 33.3. We know that deceleration is minus 8.7. We know that it's going to come to rest, so we're looking for v. Sorry, we know v is equal to 0, and we're looking for s. So, of course, the equation which uses those 3 things is v squared equals u squared plus 2as. So this is 0, 33.3 squared, times 2 times minus 8.7 times s, which we need to know. So when you bring this part across, it becomes a negative, and then you're going to divide by 2 times minus 8.7, And the answer then comes out to be 63.9 metres. And then the last part of the question, again a nice easy equations of motion question. Calculate the time. So you can use any equation you want because you know everything from above here now. So we'll just use v equals u plus at, and therefore rearranging that, t is v minus u over a, and v is equal to 0, u is 33.3, and a is minus 8.7, because you can't have a negative time, of course, and that time comes out to be 3.83 seconds.